Lesson 4, Graphing Parabolas. So there's multiple ways you can graph parabolas. The first way is to find your x-intercepts. So for the first one we have 2x squared plus 14x plus 12. To make this easier, we'll divide by 2 first. So we have x squared plus 7x plus 6. We want to find two numbers that add up to 7 and multiply to get 6. Our two numbers would be 6 and 1. Because our a value is 1, we can go right to the brackets. So we have x plus 6, x plus 1, which means that our intercepts are at x equals negative 6 and x equals negative 1. So we can go ahead and plot those points, one at negative 1 and one at negative 6. 2, 3, 4, 5. Oops. So there's our two x-intercepts. Now we need to find our vertex. So we find our x by finding the number in between our two intercepts. So we have negative 6 minus 1 divided by 2 is negative 3.5. To find the y value in our vertex, we plug in the x value into our equation. So we have negative 3.5 squared times 2 plus 14 times 3.5 negative plus 12, and you should get negative 12.5. So when we plot this, we're going to go up by 2's. So 2, 4, 6, 8, 10, 12.5, 1, 2, 3.5. The vertex should be right 1, 2, 3 here. And once you have that, all you need to do is connect the points and show that the number goes on forever. Except be more accurate than I just was. So your parabola should look something like that. So that looks better. So that is how you graph in, if you have a standard form, find your x-intercepts, find your vertex, and connect the points. Okay, the next three graphs are already in graphing form. So when you're doing graphing form, you first have to find your vertex. So your vertex is P and Q. So for the first one, our vertex is at 3 and negative 4. And always remember you do the opposite sign for your x value. The vertex for our second one is at negative 2, opposite sign, and negative 1, keep this sign. And for the last one, since we have nothing in the brackets, our x is 0 and our y is 5. So there's our three vertexes. If you want, you can go plot all of those. 1, 2, 3, 2, 3, 4. Oops. So we have 1 here. We've got another one here. Oops. That should be positive 3 and negative 4. Why is this so hard? Okay, one at negative 2 and negative 1, and the last one at 0 and 5. So those are three vertexes. Now, when we're graphing, the stretch is this number right in front. And if you were to imagine a normal parabola, if we were just doing a normal parabola, which would be y equals x squared, if you move 1 from the vertex, 1 squared is 1. If you move 2 from the vertex, 2 squared is 4. If you move 3 from the vertex, 3 squared is 9. So that would be a normal parabola. The only reason these ones are different is that they're multiplied by whatever that number in front is, that a value. So we're just going to multiply each one. So for the first one, it would be 2 times 1, which is 2. It would be 2 times 4, which is 8. It would be 2 times 9, which is 18. And really, that's about as far as you can go. You can only really ever do the first couple. So what that means is that when we start at our vertex, if I move over one space xy's from the vertex, my y goes up 2. So if I go over 1, up 2, my next point is going to be right here. If I go 2 over from the vertex, I'd go over 2. So I'd go over 2 and then up 8. So 1, 2, 3, 4, 5, 6, 7, 8. So right here is my next point. Don't draw all those little points in. I'm just trying to show you how to do this. So if you go 2 over from the vertex, you go up 8. So then you can connect your dots, and that is your parabola. So we can do the same thing with 0.5. So we do 0.5 times 1, which is 0.5. We do 0.5 times 4, which is 2. 0.5 times 9, which is 4.5. So when we start here at our vertex, when we go over 1, we go up a half. Oops. If I go over 2, I go up 2. Over 2, up 2. Always start from your vertex, not from the last point. If I go over 3, I go up 4.5. This would be in here. So this would be your parabola. And for the last one, if we went over 1, it'd be -3 times 1, which is -3. This would be -3 times 4, which is -12. And this would be -3 times 9, which is -27. And for this one, because it's a negative, now it opens down. So from the vertex, if I go over 1, I go down 3. Right here. And you can do it on both sides. If I go over 2, I go down 12. Which is down here. And you can do it on both sides because it is symmetrical. And then you connect your dots.